Only two horizontal forces act on a 3 kg body that can move over a frictionless floor. One force is 9 newtons, acting due east, and the other is 8 newtons, acting 62.3 north of west. What is the magnitude of the body's acceleration? Now let us solve this problem. Let us have first an illustration so we can understand it better. So let be our given as shown in the illustration. Let's say this is the body represented by this box. Then the mass is 3.0 kilogram. Then there are two forces acting. One force is 9 newtons acting due east. So let's say force is acting due east on this direction. Let's say this is force 1 equal to 9 newtons. Then we have the second force equal to 8 newtons at an angle of 62.3 north of west. Let us locate that force. So first one is just going east. So this is our north, this is the south, this is east, and this is your west direction. Now the second force is 8 newtons, 62.3 north of west. So that force is located in this direction. So this is your F2 equal to 8 newton at an angle of 62.3 north of west. This is your north of west, 62.3 degrees north of west. So that is your angle. So we have now two forces, and we are required to get the acceleration. So what is the magnitude of the body's acceleration? Of course, the body will accelerate horizontally. So we are looking for acceleration sub x, or the horizontal acceleration. Okay, so let us find this ax, or a sub x, the horizontal acceleration. We all know that uh, force is equal to mass times acceleration. So this is our solution. So force is mass times acceleration. Therefore, acceleration is equal to force over mass. So at this point, we are looking for acceleration x. Therefore, what we will just be considering is also the forces acting on the x-axis. Now, if we will try to look at our figure, what are the forces acting on the x-axis? So the forces acting on the x-axis is F1, of course, going east, 9 newtons. And the x-component of F2, where the x-component of F2 is this. So if we will project the x-component of F2, this is let's say F2x. Let's say that is F2x. So we have now two forces on the x-axis. F1, it is just lying on the x-axis, going on the east direction, and going on the west direction is the x-component of F2. So therefore, this summation of Fx, the total forces acting on the x-axis, is just, if we will put it in our equation, is just the sum of F1 plus negative F2x. F2x is negative because F2x is going to the west direction or to the left all over the mass of the object or the body. Let us try to solve. F1, we have 9 newtons. We have 9 newtons minus F2x all over the mass equal to 3 kilogram. Now, how can we get F2x from our figure? So from our figure, F2x, this is 62.3 degrees. We need to use cosine of this angle to get F2x, because cosine 62.3, okay, cosine 62.3 degrees cosine 62.3 degrees adjacent side F2x all over the hypotenuse, which is F2. Therefore F2x is equal to F2 cosine 62.3 degrees. Therefore F2x is equal to 8 cosine 62.3. So this is now our F2x, and we need to substitute this on our equation. So let us now solve for this equation for acceleration. We now have acceleration x, therefore is equal to 9 newtons minus 8 cosine 62.3 degrees all over 3 kilograms. So let us solve. 9 newtons minus 8 cosine 62.3, 8 cosine 62.3 degrees is equal to 3.72. So approximately 3.72 newtons all over 3 kilograms. So all from our calculator, that's 9 minus the answer. So this is 5.28, 5.28 newton all over 3 kilogram. So we all know that newton is kilogram meter per second squared. So kilogram will be cancelled. What will remain is the meters per second squared, which is the unit of our acceleration. So our acceleration x is 5.28. 5.28 divide this answer by 3 kilogram. The answer now will be 1.76 meters per second squared. So the acceleration of the body is 1.76 meters per second squared. So this is now our answer. 1.76 meters per second squared.